whichever form you want it in, and the form I do want it in is I'm going to get rid of my A2s. So I'm going to take that and substitute it there. So I now have x prime is equal to a1x plus a1v times time. I can factor a1 out. Oops, sorry, I lost my negative sign. Negative. So x prime is equal to a1 x minus vt. So we had 4 unknowns, now we have 3. We just have to figure out what a1 is. So I know what I had written before, again, if there's that flash of light, I have those 2 different reference frames. I know that x squared plus y squared plus z squared is equal to c squared t squared. Just basically the formula of a sphere. And I also know it should also be true in the prime frame, so x prime squared plus y prime squared plus z prime squared is equal to c squared t prime squared. I'm going to make substitutions based upon these 2 formulas right here. Well, actually, that formula right there and this formula right here. So x prime is, so that's a1 x minus vt squared plus y squared plus z squared equals c squared times t prime squared, so that's b1 x plus b2t squared. And now we just have to sort of expand that, do a little binomial multiplication. So I got a1 squared. Don't I keep that? Go ahead and factor the a1 in. I do. So if I factored in and squared, I get a1 squared x squared minus 2 a1 squared x vt plus a1 squared v squared t squared plus y squared plus z squared equals c squared b1 squared x squared plus c squared 2 b1 b2 xt plus c squared b2 squared t squared. Now I step back and see if I made a careless error somewhere. So that's x squared plus 2xvt plus minus 2xvt. I put it correctly there. And then got the a1 squared distributed. And then got b1x squared, b1b2 xt. I think I have not made a careless error. Do a dramatic pause for you to catch up in writing and to ask any questions. All right, so let's get it into something like this form right here. So I'm going to get the I'm going to get my x squared terms together, my y squared terms, my z squared terms, and my t squared terms. So my x squared, I've got this term right here, and that term right there. I think those are my only terms with x squared in it. So this becomes x squared a1 squared minus c squared v1 squared. Now I want my times by see what else we can get together. So our y squared terms, fortunately we have only one, so plus y squared plus z squared. And then and then on this side over here, I want to get my c squared, t squared terms. So I've got this one right here. And that's it. Oh, actually I want my t squared, not the c squared, t squared. So I have c squared v2 squared. And then I got my t squared term there. So minus a1 squared v squared. And then I've got the leftover stuff. So minus 2a1 squared x vt minus 2c squared v1 v2 xt. Did not quite give myself enough room there. I'm going to rewrite that. Minus 2c squared v1 v2 xt. Quick check to make sure that there are less errors. Okay. All right, so I have this equation here, but I also, again, I have these two different reference frames. I should be able to derive one from the other. And so I took my prime frame, I put it in terms of non-prime, and so that equation should match this equation right here, the unprimed one. Well, I know that my coefficient of x squared here is 1. So if this is all valid, 1 equals a1 squared minus c squared b1 squared. Coefficient of y squared is 1 in both cases, z squared is 1 in both cases. My coefficient of time squared is c squared. So on the top equation I have c squared. And down here I've got c squared b2 squared minus a1 squared v squared. So I'm just matching up coefficients. And then I've got this last little piece here which doesn't exist up there. So I have negative 2a1 squared x vt minus 2c squared b1 b2. And my c's are just getting worse and worse. B1, B2, xt. That better be equal to 0. I have 3 equations, 3 unknowns. So if I take my first equation, solve for B1, my second equation, solve for B2, I can plug into my third equation and should be able to solve for A1. So B1 squared is equal to A1 squared minus 1 over C squared. This one right here, B2 squared is equal to C squared plus A1 squared V squared over C squared. And then my third equation, well, let's get rid of stuff. The common factors I can just divide out because I have 0 on the right-hand side. So if I divide by anything, on the right-hand side stays 0. So X goes away, t goes away, 2 goes away, the negative goes away, it'll come back. So I'm left with a squared, a1 squared, v equals, bring this over, negative c squared, b1, b2. Now I have b1 squared and b2 squared. If I took the square root of both sides, I'd end up with a plus or a minus, and down here, I don't want to have to deal with that. So I'm just going to square what I have here. So I get a1 to the fourth v squared is equal to c to the fourth b1 squared b2 squared. Because I have a formula for b1 squared and b2 squared. We'll resolve the plus or minus in a moment. So therefore, a1 to the fourth v squared over c to the fourth equals a1 squared minus 1 over c squared plus a1 squared v over c squared. So I now have one equation, one unknown. I can solve for a1 easily enough. First off, if I multiply both sides by c to the fourth power, my denominators go away. So if I multiply everything here by c to the fourth, then that will cancel out with the two c squareds there and the c to the fourth there. Questions to hear before I start a new page? a1 to the fourth v squared equals, jump back here for the v squared, a1 squared minus 1, a1 squared minus 1 times, wrong way, c squared plus a1. Oops. Oh, there should be a squared there. C squared plus a1 squared v squared. C squared plus a1 squared v squared. Okay, matches what I have there. FOIL. So a1 to the fourth v squared is equal to a1 squared c squared times or plus a1 to the fourth v squared minus c squared minus a1 squared v squared. Conveniently, they cancel. I'm solving for a1 squared, so when I get them on one side, so I'm going to take them over there. Actually, I'm going to take the c squared over there, so I get c squared is equal to a1 squared c squared minus a1 squared v squared, which is a1 squared c squared minus v squared. And so a1 squared equals c squared divided by c squared minus v squared. So multiply top and bottom by 1 over c squared. 1 over c squared. 1 over c squared. And over here I get 1 on top. And on the bottom I get 1 minus v squared over c squared. Wow, that looks really familiar. So a1 equals plus or minus the square root of 1 over 1 minus v squared over c squared. In other words, plus or minus gamma. Shocking, gamma showed up yet again. But it's going to be plus or minus, it's one or the other, it's not either. So we had x prime was equal to a1 x minus vt. If I have an object like the scenario over here where it's moving to the right, if I have some event x prime that is still to the right of s prime, and I have x and it's to the right of s, or where x is equal to 0 for s, these both have to be positive. I'm not going to have x prime and a negative x, given that my speed, the way I've defined my speed over there. So the positive solution is the correct solution. So I have my first of what are called the Lorentz transformations. Important enough to write over here. X prime is equal to gamma x minus vt. That assumes that the prime frame is moving away from moving in the positive x direction. Dramatic pause for people to catch up in writing and to ask questions.
Can you go back one page?
There?
Okay, yeah.
Oh, you just need to check something?
Just one.
Okay. It was really convenient that I eventually figured that out. Okay. All right. Other questions?
What was x prime relative to x again?
X prime is, from the rocket's point of view, the location of an event, and x is from the Earth's point of view.
Okay, so just two different points of view of the same.
Yes. This is the translation from one point of view to the other point of view. Hopefully it'll become clearer when we deal with the, similar to the car garage problem. It'd actually be a pole and barn problem, but hopefully you can make the connection. All right, so now we have A1. We now have to solve for B1 and B2. I know that B1 squared is equal to A1 squared minus 1 over C squared. I know what A1 squared equals. That's basically gamma squared. I want to keep I want to take it out of, well, let's do gamma squared minus 1 over C squared. 1 over 1 minus beta squared minus 1 over C squared. So now it's just a matter of taking our complex fraction here and getting it into a single fraction. So if I multiply top and bottom by 1 minus beta squared, I get 1 minus beta squared over C squared 1 minus beta squared. Which equals beta squared on top, and on the bottom, C squared 1 minus beta squared. Let's go ahead and substitute the formula in for beta. What is beta?
V over C.
So I get V squared over C squared over C squared times 1 minus V squared over C squared. So distributing, so I get V squared over C squared times C squared minus V squared. So what form do I want it in the end? I have no pen. There we go. There's a mistake in my notes here. I have not gotten that far. This is not wrong. which is v squared, over, yeah, I factored out too soon, c to the fourth, 1 minus beta squared. So I have 1 over, again, I can multiply anything by 1. So I got 1 over 1 minus beta squared, which is just gamma squared. And so I got v squared gamma squared over c to the fourth. So b1 is plus or minus the square root of v squared gamma squared over c to the fourth, which is plus or minus the square root of, let's say plus or minus the square root of since I'm cleaning house here, equals plus or minus v over c squared times gamma. Again, we have to resolve this plus or minus. And I'm going to wait to do that. That's just sort of where we are right now. It's one or the other. All right. Any questions before we go to a new page? Solve for B2, and then we will come back and figure out the plus or minus based upon that. I know that B2 squared is, before I had it in before. Oh, there we go. The form I had before was c squared plus a1